use the first derivative to find the location of all local extrema for f of x equals x cubed minus 3x squared minus 9x minus 1. Well, let's begin by taking the first derivative. First derivative there is 3x squared minus 6x minus 9. Now we'll want to set this equal to 0, so factoring will work here. Take out a 3, squared minus 2x minus 3, and that is going to factor as x plus 3, x minus 1. No, let's change that. X minus 3 minus 3 plus 1. All right, so we have critical points at x equals 3 and negative 1. 3 and negative 1. All right, so let's make a sign diagram. Right, so the derivative is 0 at those points. So negative 1 and 3, the derivative is 0. And I'm going to go ahead and draw this with a flat line. That's a horizontal tangent there. All right, so if we look at that, now let's test the intervals. So if I plug in 0 into my derivative, I get a negative value. So it is decreasing in that interval. If I plug in a value of 4, that is going to make for a positive function, so it's increasing there. If I plug in negative 2, it will be positive. So I can tell you my function is increasing from negative infinity to negative 1, not including negative 1. And it's increasing from 3 to positive infinity, decreasing between negative 1 and 3. All right, so that tells us we have a local max at x equals negative 1 and a local minimum at x equals 3. All right, that's what we were after. Those are the location of our extrema. Next, use the first derivative to find the location of all local extrema for f of x equals 5x to the 1/3 minus x to the 5/3. All right, taking the derivative of that, we get 5/3 x to the negative 2/3 minus 5/3 x to the the positive 2/3. Okay, so if we set that equal to 0, actually first, well, we are going to set it equal to 0, but let's rewrite this. This is 5 over 3. I'm going to go ahead and factor that out. That would be 1 over x to the 2/3 minus x to the 2/3, which is equivalent to 1 minus x to the 4/3 or x to the 2/3. Okay. Setting that equal to 0, we find that we have critical points at x equals plus or minus 1. And we also have a critical point at x equals 0 because the derivative is undefined at that point. So let's test these points. We have 0, 1, negative 1. So the derivative is 0 at plus or minus 1, and it is undefined. It's a vertical tangent at that point. Okay, so if we evaluate points in those regions, so say positive 2. At positive 2, our function is decreasing. At, say, 1/2, our function is increasing. At negative 1/2, our function is increasing. And say at negative 2, our function is decreasing. So we've got something happening kind of like this. All right, so this function appears to have a local minimum at x equals negative 1, a local maximum at x equals 1, and that point 0 is neither a maximum or a minimum because the sign of the derivative does not change.